Okay, so synthetic division. This only works when you're dividing by x minus k. So for this first one here, this has an x squared, we see right here. So it's x squared minus 5. We cannot use synthetic division for that. Because it has that x squared, we would have to. We would have to use long division. Now, the next one is x plus 4. We can use synthetic division because we can think of that as, oh, x minus a negative 4. So our k, negative 4, we're doing the opposite. So I just want to make that note. It is the opposite of this. Very important fact. So when we're doing synthetic division, if it's a plus, we're going to use a minus. If it's a minus, we use a plus. So let's get in to see what synthetic division is. That's just telling us, hey, when can and can't we use it? Okay. So for synthetic division, I thought I had written out steps here, but we'll get them. So we always want this to be the opposite. We're going to divide here. So x minus 5. Since that's a minus 5, I want a plus 5. So this is the opposite. Now here, we cannot forget 0 placeholders. So you guys were doing a great job recognizing, like, oh, wait, there's a missing x term there. Put the 0 in. So we just use the coefficients of this. So this is going to be 2, 0, 5, 0, and negative 3. So these are the coefficients. Make sure I'm spelling the word coefficient right. So coefficients are what we are dividing. Do not forget 0 placeholders. Just put that note over here. Okay. Now what we're going to do, this is essentially 2 steps here. We're going to add, multiply. So what we're going to do is, here there's nothing to add, so this just gets brought down as a 2. So what I'm now going to do is take this 5 and multiply here. So 5 times 2 is 10. That comes up to this next slot. Do we have questions about where this is coming from right now, where I got that 10? So I brought down the 2. 5 times 2 is 10. Then we're going to add and multiply again. I'm not seeing or hearing any questions. So 0 plus 10 is 10. Then I'm going to have to do, 5 times 10, that's 50. These numbers are getting big on us. So 5 plus 50, 55. That was fourth cubed squared x. Okay. I just, it's been a while since I've done this one, so I just didn't remember the numbers getting so big, but they do. Okay, now I'm going to do 55 times 5. That gives me 275. Okay. Add those. That's 275. I'm going to do 275 times 5. Oh, now that I see this end number, yeah, I do remember this. So then that is just 5 times 275 gives me 1,375. And then that gives me a remainder of this. So now to write our answer, we go writing the answer, reduce the power by 1. So right away, this started off with to the 4th. So this is going to start off with 2x cubed. Then that's going to be 10x squared. Oh, I just want to put this here, that this is the remainder. Then that's going to be plus 55x plus 275 plus that I do by remainder, this over x minus 5. And that's using synthetic division. Before I move on, we do have more examples with this, and we'll talk about this a little more in depth. But do we have any questions on this? So this is bring down, multiply, add them up, multiply, add them up, multiply. So it can be hopefully a rather quick process compared to the long division. I'm not seeing any questions pop up, but if they do, just let me know and we'll go back. So here's another example. Okay, so I start with drawing this box here. Let's see, it's a +3. So I'm going to change this to a -3. And then I'm going to pull my coefficients, off of here. Now, I do notice I'm missing an x cubed term. So it's going to start out 1, 0 for that missing x cubed, -10, -2, and 4. Okay. Since I don't have a number down in this area right now, I just bring down the 1. Then I'm going to do -3 times 1. That's -3. And before I start the next loop, again, I do want to take a quick pause for questions. Okay, I'm not seeing any in the chat. Nobody is unmuting themselves. So we add 0 plus -3, -3. Now, you can do this without drawing arrows. I like drawing the arrow. I am so sorry about that, guys. It looks like it's still recording. Let me get that back to sharing, and we'll just run through the very beginning of that a little bit quicker. As I don't think it saved what I wrote. Nope. Okay. So again, draw my little box for the synthetic division. This was -3 in front. My coefficients are 1, 0 because there's no x cubed, -10, -2, and 4. Start with bringing down the 1 because there's nothing to add there. 1 plus nothing is just 1. Now I'm doing my multiplying. -3 times 1 is -3. 0 plus -3 is a -3. -3 times -3 is 9. It's a positive 9. -10 plus 9 is, what's that? -1. -3 times -1 is positive -2 plus 3 is 1. -3 times 1 is -3. Add these up and I get a 1 here. So I do technically have a remainder of 1. So I'd like to box that remainder just so I remember that it's what it is. So go 1 power lower. It starts out to the 4th. So I want to start out cubed. So that's just going to be x cubed minus 3x squared minus 1x plus 1. And then I have my remainder plus 1 over x plus 3. So that is our next example. Again, not seeing anything in the chat right now, but if you do have questions, utilize the chat, please, or unmute yourself. Just I'll check in how much time we have left. Good. We got 20 minutes left. I should be able to get through everything in that time. So that's synthetic division. Now look, we could have done this using long division. For time's sake, I'm not going to bother doing that. But could always do long division instead of synthetic. But I find synthetic far faster. So when I can use it, I like to use it. Okay. Let's take a look at the next example. So here's another example with this. This one has a negative right here, so I want to flip that to a positive 1. Now this one conveniently has all the terms I need, so I flip this to a positive 1. So it goes x cubed, x squared, x whole number. So I don't even have to write 0 placeholders in here. Start with bringing down the 2. Okay, again, now we're multiplying here. 1 times 2 is 2. 3 plus 2 is 5. I didn't have to put any zeros in here because it goes cubed, squared, x, and 3. So that is a great question. Or the previous ones, because we were missing terms, I had to add in zeros, but because here I'm not missing any terms, there are no zero placeholders. Excellent question. Thank you for bringing that up. Okay, so then I did 3 plus 2 is 5. Oh, 1 times 5 is 5. Let's see. -8 plus 5, -3. And now I do 1 times -3. Oh, that's just -3. Oh, this one's neat. This one has no remainder. So 0 is the remainder. So this is a no remainder, which means x minus 1 is a factor. So for this, it starts out cubed, so I go down 1 to squared. So 2x squared plus 5x minus 3. And that is that problem. Any questions so far about this? That was a great question about the zero placeholders missing. Any other questions we have, please make sure to ask. So essentially, what I'm bringing up here, because this has no remainder, me calling x minus 1 a factor is essentially covering what the factor theorem says. The factor theorem says, hey, if 0 is the remainder, it is a factor. Okay, not seeing any other questions pop up in the chat. Nobody is unmuting themselves, so going to clear this and move on to the next part of the notes. So here with this, this is the first part of your classwork when I did it last year, right before things changed with COVID. You know, it just got chopped up a little bit. I think there was something happening in the school that day that I had to put it as 2 parts. You're going to get 6 problems to have finished by Friday. So for your homework tonight and your asynchronous work, those are the first 3. Those just deal with, hey, just do the division. Now we're going to talk about the remainder theorem and the factor theorem. So we can use synthetic division to basically plug in a number. So if we do synthetic division, whatever the remainder is, that's what the value is if we were to plug that in. With the remainder theorem, we do not do the opposite. So what I'm going to do right now is I'm going to do this the old-fashioned way. I'm going to plug 5 in. We're going to do it that way, and then we're going to do it using this remainder theorem. So you may have said, oh, I can do f of 5 is equal to 2 times 5 to the 4th plus 5 times 5 squared minus 3. Let's see, 5 to the 4th, that's getting awfully big. I'm definitely going to need a calculator for that. Pi to the fourth is, I know it's like 1,000 something, I believe. There we go. Oh no, sorry. So that's 2 times 2 or 625 plus, see, 5 squared times 5 is 125 minus 3. So let's see, 2 times that would be 12,500 plus 125 minus 3. So then that's just equal to this. Minus 3, which is this. Not horrible, but that wasn't the easiest number to plug in. We actually already did this synthetic division earlier today in our notes. We're just going to do it again. So remember, remainder theorem, don't do the opposite. So this stays 5. I pull my coefficients from here. 2. This does have an x cubed, so that's 0. So that gets back into, why didn't I do it on the last problem? I wasn't missing any terms. Why am I doing it on this one? I'm missing an x cubed. Then 5x squared x term, so I put in that 0 there, minus 3. Bring down the 2. 5 times 2 is 10. 0 plus 10 is 10. 5 times 10 is 50. That's going to be 55. 5 times 55 times 55 is 275. 0 plus 275 is this. 5 times 275 is 375. I just remember that from doing that earlier. And lo and behold, here's my remainder. So I know f of 5 equal to this. Same answer we got doing it the other way. So at the end of the day, it really doesn't matter which way we do it, but this synthetic division, definitely if I had a larger number in there, like if I'm trying to take let's say 7 to the 5th power, you guys would be looking at me like, really? You want me to do 7 to the 5th power? But if we do this synthetic division, usually it's like, okay, that wasn't too bad. That was just some high number multiplying, but it didn't feel as stressful, hopefully. Okay, let's clear that. Okay. So for something like this, for the factor theorem, use synthetic division. If the remainder is 0, it is a factor. So we're going to check if this is a factor, then talk about the last piece of the notes there. So here with this, since this is saying the x minus 2, we're still doing the opposite on this. So that's a 2 there. Draw my partial box. Then this says, let's see, 2x to the 4th. Then that's 7x cubed minus 4x squared minus 27x minus 18. No terms are missing, so no zeros needed. So hopefully I get this as 0 at the end. If it is, I say it is a factor. If I get something other than 0, it is not a factor. So bring down the 2. 2 times 2 is 4. 7 plus 4 is 11. 2 times 11, 22. Negative 4 plus 22 is 18. 2 times 18 is 36. Negative 27 minus 36 will give me 9. 2 times 9 is 18. And negative 18 plus 18 is 0. So I'm going to say remainder equals 0. X minus 2 is a factor. Now, we could take the time if you wanted. You could put that into Desmos, and you would see at positive 2, you do get a 0. Again, confirming that that is a factor. Before I move in to the last part, sorry about that. I am back. Let's look at that very last page. It's just a summary of a lot of what we said. So I am pulling that back up. Sorry about the minor technical issues. Come on, let's get to the last page of this. Okay. So some facts about the remainder are when we're using synthetic division. The remainder, when x is equal to k, is the value of f of x. So if the remainder equals 0, then minus k is a factor of f of x. If the remainder equals 0, then k comma 0 is also an x-intercept. So I'm giving you 4 more problems to try on page 125. That is going to be 44, 46, 52, and 54. So you have 7 more problems to try and get done. I believe I put this assignment. Oh, I need to double check. I think I either put it due Friday or Monday. I put it due on Monday. So Friday, I'll take any questions we have, do our usual check-in for the week, and all that. So let me stop recording.